Okay, so this right here is a really complicated case where you have two functions with even powers, and I'm only doing powers 2 because, again, everything higher than 2 would be a complete mess. So the first thing that I'm going to do is to rewrite everything in terms of one function. And it doesn't matter which one, so let's say if I take sine squared and I'll replace it with 1 minus cosine squared x, then the integral becomes cosine squared x times 1 minus cosine squared x dx, which equals to cosine squared x minus cosine to the fourth power x. So I can actually split them in the middle and use two integrals, but regardless of how I proceed, I need to use my power reducing formulas. So in the previous video, you saw how we can replace cosine squared with 1 plus cosine 2x over 2, so that's just one integral, minus the other one. First, I will rewrite cosine to the fourth as cosine squared squared, and then I can use my power reducing formula, drop the power of 2, I'm copying this over, not doing any calculus yet, no calculus there, just rewriting. So cosine squared becomes 1 plus cosine 2x over 2 quantity squared. So let me focus on this expression. 1 plus cosine of 2x over 2 squared. If I square that, that equals to 1 plus 2 cosine of 2x plus cosine squared of 2x all over 4. I have another problem. I have another power of 2. I need to do that. So I will use the power reducing formula again. I'll show you how that's done. So in order for me to make it easier on the eye, I'll just divide everything by 4. Little terms, so 1/4 plus 1/2 cosine 2x plus 1/4 cosine squared of 2x. And I'm just going to apply the power reducing formula term again, e to the power 2, 1/4 plus 1/2 cosine 2x plus 1/4, and then using the power reducing formula, I get 1 plus cosine double angle, so that's 4x now, doubling 2x. So overall, this is 1/4 plus 1/2 cosine 2x plus, I have 1/4 times, right here is 1/2, that's plus 1/8, then plus cosine 4x over 8 as well. So now, then I can combine like terms, 1/4 plus 1/8, what is that, 3/8, I believe, plus 1/2 cosine 2x plus 1/8 sine of 4x. The good news, there are no powers of cosine. Maybe it would be a good idea. Remember how we had two integrals? This is what we just dealt with, squaring the power. That was my idea. And we also have this integral. Okay, I shouldn't have split them into two. That's not. important. I can actually now simplify this. If I combine these two expressions, so the first integral is 1/2 plus 1/2 cosine 2x. This was the first integral right here. And then it says subtract integral big one, the one which is dealt with. Again, not doing any calculus yet. So I'm just copying this over here. 8 plus 1/2 cosine 2x plus 1/8 sine of 4x equals to, no calculus, just trig and algebra. 1/2 cosine 2x minus 18 minus 1/2 cosine 2x minus 1/8 cosine of 4x. Right away, we see a few things. 1/2 cosine 2x cancels with 1/2 cosine 2x. And I can combine 1/2 minus 8. 1/2 minus 3/8 is 1/8 minus 1/8 cosine of 4x. My original problem turned into this. So therefore, that's what I have to integrate. Integrating 1/8 minus 1/8 cosine of 4x x equals, I can factor 1/8 out, but 1/8 x minus 1/8. Then the integral of cosine of 4x is sine of 4x, but I also need 1/4 to offset the 4 on the inside. But overall, we ended up with 1/8 x minus 1/32 sine of 4x plus a constant.